Microsoft Azure recently added two new topics in their certification AZ 104. First one is Azure Container Instances, and second is Azure Kubernetes Services. So, what are containers, or better to say, Docker containers? What advantages the Docker containers or containers in generic bring over virtual machines? How does Docker container architecture look like, including the components that make a Docker? How is Kubernetes different from Docker containers? Or how are Docker containers related to the Kubernetes? And how are Kubernetes services implemented in Azure? I'm going to cover all this in today's episode. Welcome to another episode of a weekly video series with me, Atul Kumar from Team K2 Academy, where we help you in your journey to cloud, where we take you from complete beginner, that's stage one as your fundamentals, to stage two, which is as your administration, to stage three as your DevOps or as your solution architect, to all the way to as your specialist. So to give you some context before I tell you about what is a container, a Docker, or Kubernetes or Azure Kubernetes. In the previous episode, I discussed about what's changed between 104, AZ 104 and 103. And since then, I got a lot of messages related to asking about this container and Kubernetes. Apart from that, I also have a 2 hours free training telling everything about Azure Administration Certification. So I get a lot of questions in that related to this topic. So if you are not yet Azure Administration Certified or AZ 104, and if you want to get hold of that free training, I highly recommend you to register for this free 2 hours free session with me and Microsoft Certified Trainer by going to this URL k2academy.com/AZ10402. We'll talk everything about certification, how you can prepare about that. So let's first begin with today's topic about what is a container and or what is actually Docker container means. So containers provide you the virtualization so that your application can run independent with all its dependencies independent to other applications. You have a container one and then container 2. In container 1 you're running application 1, which could be a web server. In container 2 you're running a database, and container 3 you're running a third application. All its dependencies are bundled into as a one package, and you can deploy independent of a operating system that you're running that container engine on. So if you're coming from a virtual machine background, you might ask what advantages Docker have over the virtual machines. We have already been running VMs for quite a number of years now. So if you notice, the major difference between a virtual machine compared to container is that the containers run within the same kernel of operating system, whereas in virtual machine you have a separate kernel or separate operating system for each virtual machine. And that's what makes containers so popular in recent years. Now, is Docker the only container option? Answer is no, but Docker is one of the most famous container engines. Linux by default comes with its own container engine, and then you have other container options like from Microsoft, you have a Microsoft container instance, or Google, or Amazon AWS, or Oracle. All those big companies have their own container engines, but Docker is one of the most common ones or famous ones. So what makes container options better compared to virtualization? As I said earlier, the containers share the same underlying kernel, whereas the virtual machines, they have their own kernel or they have their own operating system. And hence, if you see in terms of resource utilization, the containers are very lightweight. Similarly, if you look at the size of the container compared to the size of the virtual machine, container sizes are very small. And similarly, they start very quickly within seconds. That's what makes containers quite very popular. Now, as I said earlier, people use containers and Docker interchangeably, but Docker is not the only container option. When you're implementing in Microsoft Azure, you'll be using Azure container instances. Now, if you look at the Docker architecture, and I'm using word Docker, but it can use it interchangeably with a container. So you have a host in which all your containers are run. So in this case, on a host, I've deployed a Docker server, and in that I have multiple containers running. Now, these containers are instantiated or runtime instances, which are launched using something called as the container images. and you have a client. These client basically talk to your Docker host using APIs or command line interfaces. Yeah. Now these images are stored in something called as image registry, or we call Docker hub or container registry. So this is all in a nutshell about very high level 30,000 feet view about containers or Dockers. So containers let you run your applications independently, multiple applications within its own container independently without impacting other applications, including all its dependencies. So using these Docker images, you create multiple container instances from one single image, or you can create your own image from a Docker instance. So Azure Container Instance is an implementation of containers on Microsoft Azure. Then the next question comes, what is then Kubernetes, or what role does Azure Kubernetes play? So in order to understand this, the role of Kubernetes, let me go back to this Docker architecture. Now, in a typical implementation, you will not have just one or two containers, you will have hundreds of containers, and you want someone to manage these containers. You want someone to orchestrate or start, stop, control, destroy, and do all kind of a management of these containers. And this is where the Kubernetes service comes into picture. So you have a management node, which basically acts as a management engine to manage all your container instances. So in this deployment here, you have a master node, which Microsoft Azure provides you absolutely free. And with that, you get multiple worker node, each running its own container engine. And that's where the Kubernetes comes into picture. So Azure Kubernetes service is an Azure's implementation of that Kubernetes engine on Microsoft Azure cloud. And you can use either Microsoft Azure portal or CLI or ARM template to create these Kubernetes clusters. If you're new to the Docker containers or Kubernetes concept, it could be confusing to understand how these are implemented in Azure cloud. So we have Azure Administration Certification Training AZ-104, where a Microsoft certified trainer and Azure expert Eva covered this as a dedicated module, a full day session on this topic. So I've taken out some clips from that training where Eva first discussed about the role of containers and how these containers are implemented in Azure, then discusses about the role of Kubernetes in orchestrating and integrating these hundreds of containers those are implemented on cloud. She also talks about Azure Container Service master node, which is absolutely free that you get, and then these customer managed we call cluster node or worker node, and you can have multiple worker nodes based on your requirement. So let's hear Eva talking about the containers and Azure Kubernetes services.
Let's see the containerized environment. What was the inspiration behind containerization? It was actually from the shipping industry. So those days people have different types of materials to ship from one country to another country, and shipping industry find it really very difficult to accommodate. Then they came up with this containers, similar size of containers. If there are 3 cars or 6 cars that you want to uh, move. So here is the thing. And let's say a small thing, probably a refrigerator. You can keep 200 refrigerators in this container. 6 cars, 200 refrigerator. It doesn't matter. Outside, they are all containers, and there, I mean, there will not be a damage to the internal things. So you don't worry about what is happening inside. So that is the inspiration actually, which is taken from the shipping industry. So, and containers have been around for many years now, probably around 10, more than 10 years now. Very recently, it started becoming commercialized. So here also, I have my hardware. I have my operating system. On top of my operating system, I have my containerized container engine, and this is nothing but Docker. Even if it is here we call it as ACI, Azure Container Instance, and Amazon calls it as Elastic Container Service, ECI, GCE, Google Container Engine. No matter whoever calls it however they want, inside the heart of it is Docker. So that's why people, instead of calling container engine, they call it as Docker engine. So on top of my operating system, let's say this is my Ubuntu operating system. On top of my operating system, I'm keeping my container engine. And here also I have these three app dev people. Yeah, for those three languages. And straight away on top of it, they can start building their app. And there will not be a runtime error. Let's say I am the person here who wants to use, and as long as I have a Docker engine or a containerized I have a containerized environment, the apps will work. It doesn't matter which language it is. I don't need to have the runtime and the dependencies for that particular language. See, just four layers. In fact, three layers here. Here it is one, two, three, four, five, six layer. But virtualization is mandatory before we get into containerization. In your on-premise also, you can do containerization. On-premise also, you can use Kubernetes. And what is Kubernetes? Let's say I have 10 containers, I will be able to come up with better integration and orchestration. So now that is, these are some of the words. Integration. Let's say I have three different containers. Which container has to talk to which container? This container has to talk to this container, and then this person to talk to this container, and then this person to talk to this container. This is integration. If I have 1000 containers for an app, integration is a problem, and on top of it, orchestration. I need an orchestration software. What is orchestration? There is a wind instrument. There is a list of wind instrument. There are some people who play piano. There are some people who play string instruments, and there are people who sing in parts like alto, soprano, tenor, bass, different parts. But what you hear is a harmony. So that is orchestration. With thousands of containers, how am I going to come up with an orchestration? For that, I need Kubernetes. Sorry. Kubernetes, you can either deploy containers and then do a Docker compose and then put it under a orchestration part, which is Kubernetes. Or while creating itself, I will show you lab for both. Or while creating itself, I will create one master and then multiple nodes. Can I use Kubernetes in on-prem? Yes, I can, but I'm responsible to configure and maintain this master node, which is a major headache. And one more thing, as of today, cloud has given master node as free of cost. You don't have to pay for anything. So as of now, master node, no no charge, and you don't have to configure master node. The beauty is you don't have to configure master node. That's the most important part. You need to focus only on the nodes and pods. These are nodes and pods. What are these? We will see it today. Create an AKS, it comes with one master automatically, even if it is a one node. Yeah, I haven't started speaking about pods. Yeah, it is just one node. As of now, let's keep it very simple. Master node, cluster node. Even if it is one node, it is called cluster, and it comes with a particular master. And the best part is you don't have to pay for the master node. That is one advantage. But if it is your on-premise Kubernetes environment, you can have Kubernetes. It's as I said, it's a very generic technology. You can keep your on-premise. Whatever I have shown you here in the VM, you can also put it on your laptop also. I just did it in my lap. I mean, oh no, I used it. So you can do it in your laptop also with your Docker desktop. If you see the underlying component of AKS, it is nothing but virtual machine scale set. But in virtual machine scale set, in order to scale out and get my second VM, it takes 10 minutes. Here it is 10 seconds. That's the huge difference between my virtual machine scale set and Kubernetes. That is why it's, I mean, that's why Kubernetes is Kubernetes. Okay. So now this is what Microsoft is doing in the background, a master node and a cluster node outline. Within master node, there are 4 different components, which makes a master a master. This is the architecture of Kubernetes. Yeah. This is called your etcd. This takes care of the status of the cluster. I will write it in different colors later on. And then this is Kube API server. And this is my scheduler for orchestration. And I also have a Kube controller manager. What do they do? And there is also a connectivity between these. The controller manager will speak to both of these people, scheduler and API server. etcd is different. etcd takes care of the status of the cluster, entire cluster, kind of health, little bit on the health part and the configuration part of it, all the configuration files. So these 3 components work with the cluster node. Now what is the cluster? What is Microsoft, what is my Azure portal doing behind the cluster node? Yeah, it says running. Yeah, what is it doing? Here also I have 4 components. The first component is my containers. How many ever containers? So let's see, 3 containers. My 3 containers. And I also have a second component, which is my container runtime. Kubelet is the third compartment, and kube proxy is the fourth component. Okay, kube proxy works with my, what is this symbol? What is the symbol of Azure product? What is this product? VNet. So kube proxy is for your networking, Azure VNet. It works with your VNet. And your container works with your container runtime. And if I want to save the storage, I can do it via Azure disks and files, and the third party being Portworx. This company of late is getting a lot of attention. And my scheduler, and the commands, whatever the commands that I'm going to run, all the Kubernetes, like how the Docker commands all start with Docker, 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 Docker run, Docker inspect, Docker RM, Docker RMI. In Kubernetes, everything starts with kubectl. Yeah, and all these will be taken here. This is my shell. Here, the kubectl is my shell here. All the commands that I give, all the kubectl, all the commands start with kubectl get nodes, kubectl get pods, kubectl get deployment, all of these. And how there are n number of containers, there are thousands of containers. Immediately, as and when I give, immediately kubelet works with the scheduler, and scheduler works with the controller manager, and then it chooses the right set of node. Currently it is only one node and few containers. What if there are few hundreds of nodes and few thousands of containers? This is how the process is. So my kubectl commands go to kubelet. From kubelet, it goes to my scheduler. Scheduler works with the controller manager. And from here, we get to know where exactly to execute. This is the background. Why do we need this type of architecture? Because integration is not enough. integration of containers within containers is not enough. If mine is a very small application wherein I can run with few microservices and few containers, I don't need Kubernetes. I can be happy with, I can lead a very happy life with just Dockers, few Dockers and manual integration of it. I need somebody to take care of the integration and orchestration, and I need a master for all these nodes. Then it is my Kubernetes.
Well, that was Eva talking about containers and Kubernetes implementation on Microsoft Azure, including the various components that make Azure Kubernetes services, that's master node and cluster nodes. So just to do a recap, the Azure Container Instance is the implementation of containers on a Microsoft Azure cloud. And similarly, the Azure Kubernetes Services is the implementation of Kubernetes on Microsoft Azure cloud so that all the containers or hundreds and thousands of containers can be managed through the Azure Managed Cluster node, and you have the worker node, which are containers, individual containers running containers on their individual dedicated virtual machine on which the container hosts are running. Well, that's it from me, Atul Kumar from Team Keton Academy, talking about the two new services being added in the exam topics. One is Azure Kubernetes Services, and another one is Azure Container Instances. If you want to know more about Azure Administration Certification, AZ 104, then join me and Eva on a roughly around 2 hours free training on how to prepare for Azure certification AZ 104, what are the differences, exam-wise topics, and what all things you should be learning in order to clear the certification and earning a lot more in 2020 and years to come. So this is Atul from Team Keton Academy, and I'll see you next week in another episode.